Minerals are building our planet and are the part of our lives. They have an important role in many industries, also in the production of cement, which is represented by the company Salonit Anhovo. We meet the minerals all the way from exploitation of raw material to cement and at the end to concrete. Let's explore minerals in cement industry. The cement plant Salonit Anhovo and its quarry are located in the central part of Socha Valley, in the municipality of Canal ob Sochi between settlements Deskle and Kanau. The whole mighty complex extends on both sides of River Socha. Fabrika, as it is called by the locals, for almost 100 years gives bread to the local residents and others in its near and farther surroundings. The geographic location of the quarry, from where the main raw materials for cement production are supplied, certainly contributed to placing the cement plant right into this place. The area of Anhovo quarries consists of Rodeš, Perung, Lastiunica and Deskle quarries. In geological sense, they belong to the external dinarites, and geographical to the western border of Trnovo forest. Based on the geological research results, we can claim that the area of today's central Socha Valley was under the sea in the Upper Cretaceous, Paleocene and Lower Eocene. Tectonic movements and sedimentological conditions caused the occurrence of underwater landslides, known as turbidites, and debris flows. Seabed sediments, which were not yet completely petrified, have been eroded. After, slipping layers deposited in accordance with the gravity law, first larger, then medium, and finally the finest particles. Thus were formed the cyclothems, which represent a sequence of rocks and were created as a result of underwater gravity processes. Layers which were deposited within cyclothems in the area of Anhovo quarries have quite similar composition. They differ only in the share of individual rock layers. Each cyclothem consists of marly calcareous breccias, coarse-grained carbonate sandstones, medium to fine-grained sandstones, marly limestones and marl stones. The fleche sequences at the top of the marl stones consists of fine-graded carbonate sandstones which alter with mudstones, claystones and siltstones. The formation of the first Rodeš quarry is closely connected with the discovery of Ivan Nibrant, the master mason from Anhovo. In 1904, while he was cooking lime, he noticed an unknown grey powder, which later turned out to be an excellent raw material for clinker burning. Based on Nibrant's discovery, Emil Stock, the entrepreneur from Split, built in 1921 the cement plant in Anhovo. With the beginning of operation, the use of raw materials from Rodeš quarry, which is located on the left bank of Socha River, was also started. Initially, they were extracting only marl stone, which contains about 77% of calcium carbonate. Its chemical composition was optimal for the cement clinker production. At the beginning, the natural marls, as it was called, was obtained through the open-cast mining. Gradually, when the layers of marl stone on the surface were exhausted, the mining operations were redirected in the underground extraction of raw material. The difficult working conditions and higher costs of underground extraction have stimulated the research work and the search of new layers of marl stone on the surface. This research led to the opening of new quarries, Deskle and Lastiunica. The acquired raw material was in quarry transported manually with transport carts or locomotive. The transportation processes continue with cableway by the year 1973, which was held above the Socha River to the other part, where the cement plant was operating. Later, when quantities of natural marl were no longer sufficient for the cement production needs, The extraction in order to get the right composition was redirected to the rocks with different contents of calcium carbonate, approximately from 70 to 80%, which were properly mixed before the clinker burning. Today, the mineral extraction runs through drilling and mining works in Rodeš and Perung quarries. From these quarries, the material is transported with dumpers, which have the load capacity of 50 tons to the primary crusher. Crushed material is then transported with conveyor belts into pre-homogenization hall. The pre-homogenization process is carried out with a longitudinal metalling of the raw material mixture on a pile of 100 meters length, which consists of approximately 600 layers of materials with different compositions. Prepared material is taken from a pile with transverse withdrawing, which is carried out transverse to the pile longest axis, in order to ensure the homogeneity of raw material mixture. There are always two piles in the raw material hall. One is in preparation, and another is in use. Raw material mixture is transported on the other bank of the river Socha to the raw mills, where it is grinded together with additives into raw meal. The latter is stored in silos, where the last phase of homogenization is carried out. Raw meal enters the clinker burning process at the top of the heat exchanger. Then it goes through a series of 5 cyclones and calciner, where drying, preheating, and decarbonization, thermal decomposition of carbonate minerals are taking place. Hot meal with a temperature of about 900 degrees Celsius enters the kiln in the cooler part. From there it travels toward the warmer part, where it reaches a maximum temperature of 1450 degrees Celsius. During burning, the material is partially melted. This causes complex chemical reactions that led to the formation of clinker minerals: alite, belite, aluminite, and ferrite. In the final phase, the clinker is quickly cooled in a clinker cooler. The content of free lime, which has to be monitored regularly, is one of the criteria for determining the quality of clinker. Clinker minerals are clearly visible with observation under an optical microscope. The most important clinker mineral alite can be identified under the microscope by its blue color and sharp edges. It is very reactive and provides high initial and final strength in hardened cement binder. The second most important mineral, belite, can be identified by its brown coloration and oval rounded forms. The space between alite and belite is filled with aluminates and ferrites that are formed during the cooling of the melt. Clinker with added binding regulator, gypsum and various mineral additives such as blast furnace slag, fly ash, limestone or silica fume is grinded in a grey powder, cement. Mixture of cement, water and suitable aggregate is concrete, which is the most widely used building material nowadays. Its binding component is hydrated cement binder or cement stone. This occurs in the process of hydration, when cement is mixed with water and clinker minerals react with it. Formed minerals can be observed only under the electron microscope because of their small size. In the hydration of silicate phases, alite and belite, CSH, calcium silicate hydrate gel, and calcium hydroxide are formed. CSH gel is the main component, which gives the binding properties to cement stone, and thus to concrete. Its morphology is unspecified. Calcium hydroxide appears as a crystal with characteristic morphology of hexagonal lamellae. In the hydration of aluminate phases, aluminate and ferrite, so-called AFT and AFM minerals are obtained. AFT minerals are characterized by a needle-like structure, while the AFM minerals are characterized by a layered structure in the form of hexagonal lamellae. In cement binder, in addition to reactions of clinker minerals, reactions with mineral additives also occur. Minerals in concrete are crucial for the achievement of the most important properties of concrete in use. Minerals are also important in our daily lives and can tell us a lot about our past.